Remember back to when you learned about transformations? So let's say we had some graph f of x. And remember, this represents the x value, obviously, and this represents the y value. If I drew a random graph and a random curve, call that f of x, how would I shift that curve up? Add, say, 1 to the f of x, the y value. If we want to shift that graph up 1 unit, I would add 1 to the y's. So you take your x's, you plug them into the function, which creates y values, and then you add to those y values, and that will shift the graph up. If you were to subtract 4 on the outside, that would take your original graph and go down 4 units. Okay? Now, how would I move the graph to the right? Close. The left and right shift is opposite from what you think because the shift happens before you plug the numbers in. So if I were to do x minus 1 inside the parentheses, that's going to take all of the input values and subtract 1 from them, which will have the effect of moving the graph to the right. Does that make sense? It may or may not, but just remember that anything that happens to the x's is opposite from what you would think. So subtracting 1 would move the graph to the right. Adding 1 on the inside would move the graph to the left. Okay? So if we had a parabola, y equals x squared, and I wanted to move left 2 and down 3, what would that parabola look like? Left 2, so it's going to be x plus 2 squared minus 3. So that would have the effect of taking the regular parabola. Let me draw a second version of that. When we take this left 1, 2, and down 1, 2, 3, and notice that the vertex of that parabola is at -2, -3. That is our HK, right? Well, you'll notice that the H value is negative, just like the circle formula, but the K value is the same as the K value listed in the vertex. And just to keep things the same, we're going to take this 3 and we're going to attach it to the Y, just like it is in the circle formula. So the formula for this would be y plus 3 equals x plus 2 squared. That is the vertex form of this parabola. Well, how would you convert this into quadratic form, into polynomial form? Well, but this is not in polynomial form. How would you turn this into the old x squared plus x plus some constant? Yeah, the complete the square and the factoring and... Well, we just times this together. So x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4 minus 3. X squared plus 4x plus 1. So this quadratic and this formula represent the same parabola, but they have different strengths and weaknesses. This is what you use if you're looking for the roots. If you're interested in where this touches the x-axis, you have to have it in standard form, in polynomial form. If you're looking for the vertex, then you want to put it in vertex form. Okay? Well, there's one more thing we have to deal with. What if the parabola is skinnier than the one that we drew? What if I moved it and then I made it twice as skinny? How would that change this formula? We're going to multiply the x values by 2 or the y values by 2. the y values. We want to stretch it vertically. So it's going to be 2 f of, oops, that shouldn't be there, f of x plus 2 squared minus 3. So we stick a 2 right here. What if I wanted to make it twice as wide? What would I times it by? 1/2. Or you could divide it by 2. That would do the same thing. What if I wanted to flip it upside down? It would be negative out front. So if I had a negative 1/2, it's going to flip the parabola upside down, and it's going to make it twice as wide. Okay? And the vertical shift is really easy to do. The wideness shift is a little bit tricky, but you guys will pick it up. It's not too bad. So here is the formula. Y minus k equals a times x minus h to the second. That represents all parabolas in vertex form, both opening up and opening down. Now, if you switch the x's and y's, and the h's and k's, so if you had x minus h equals a times y minus k squared, then it would be a horizontal parabola, either opening to the right or opening to the left. So, a is the tricky part. If a is bigger than 1, so if you times it by 2 or 3 or 4, it's going to stretch it vertically, which makes it thinner. If a is less than 1, it's going to smash it vertically, which has the effect of making the parabola wider. So if I had y plus 2 equals 3 times x minus 1 squared, how would I graph that parabola? Where is the vertex? Well, we do the x's first. 1, negative 2 is the vertex. So 1, negative 2. No, because it's minus k. Since we move the k to the other side, it works just like the other k did. If k is on the right side, then you take it at face value. If k is on the left side, then you change its sign. That's a good point. All right, opening up or down? Up. And normally, you take your vertex and you go over 1, up 1, over 1, up 1, and that is your basic parabola. But this parabola is 3 times taller. So instead of over 1, up 1, it's going to be over 1, up 3. 1, 2, 3, and over 1, 1, 2, 3. So this is 3 times taller than the original. Does that make sense? Okay, what if instead of 3, I did negative 1/3? It's going to be 3 times wider, but it's a little bit tricky. It's not down 1 over 3. It's always over 1. Over 1 down 1/3, which is a mess. We don't want to graph 1/3, right? So you could, let's make a grid here. You don't need to do this. So you could say, if I can hold on to my markers, over 1 and down 1/3, over 1 and down 1/3, but it doesn't work that way. That ends up being a lot wider than it's supposed to be. Okay? So it's complicated. It's not worth knowing, trust me. So I could draw the parabola that way, but for some reason, and this always works, if your fraction is 1 over 3, you can invert the fraction and then go over that many and down that many. So you can actually do over 1, 2, 3 and down 1, 2, 3. And it will actually hit both of those points. So 1, 2, 3, 1, 2, 3. So if you see 1/3, just go over 3, down 3. And that will work every time. So if it's 1/5, over 5, down 5. 1/2 over 2 down 2. And if it, no, that won't work. If you had 2/3, if it's less than 1, that's what you do. Yeah, negative just flips upside down. If you had 2/3, you'd flip that upside down and get 3/2. You'd go over 1/2 and up 1/2. 1 1/2. Over 1 1/2, up 1 1/2. Okay? Or you could go over 1, up 2/3, but nobody likes to graph 2/3. Okay? So that is kind of tricky. So let's do a couple of these together. Look at number A. Where is the vertex for A? 2, 4. Which direction does it open? Up. And how open is it? It's a standard one, which is up 1 over 1. So it has to hit those 2 points right there. Okay? Where's the vertex for B? 0, -3, opening up or down? Well, the formula is y minus k, so it's the opposite of k. So it's opening up, and it's 4 times higher than it would be normally. Does that make sense, Brendan? Okay. Yeah, we put the k on the left side with the y so that it works the same way that it works with circles. Because we don't want to memorize a bunch of different rules. The A value determines how it opens, and the A value is positive, so it's going up. All right, part C, where's the vertex? 3, 5, opening up or down? Down, and it's 4 times wider, so how do we graph that? Over 4, down 4. Yep. So it would look like this. All right. Part D. What is the equation going to be for part D? Y. So the k value is -3. So y plus 3 equals, what is my A value? Not 0, 1. So we don't need it. It says right here, normal open. The other way to look would be, it hits at 1, up 1 and over 1. Well, you don't need it in this case, yeah. So x minus 3 squared. And I've written how open it is because it's a little hard to tell sometimes. So on this next graph, it looks like it hits that point, but it actually just barely misses. The first time it hits a point is way up here. So to alleviate that confusion, I've told you it's 5 times wider. So this is going to be y minus 1 equals, not 5, 1/5. Fractions are fat. Times x plus 3 squared. Does that make sense? So over here, right, fractions are the fat graphs. That's how I've always remembered it. All right, so y minus 0, which you don't actually need, so it's just y, equals -4 times x plus 1 squared. Yep. All right, you have the rest of class to work on that assignment. Should be pretty simple. I don't have answers to this, sorry. I had answers to the last one, I just forgot to give them to you.